Hello students and YouTube followers. This is Dr. Satish Singhal, PhD, Professor of Computer Science at El Camino College, Torrance, California. Here I'm doing a design example where we would like to build a software that in a pizza store process the order for one pizza, computes the cost, and outputs for the user how much they owe for their pizza. We're going to do 5 videos, and the reason for doing 5 videos is just kind of keep each video short, and so that you can also understand each video and then move to the next one. So first of all, I'm going to describe the problem. Understand that we are doing coding in C++ in command line environment. So we do not have advantages of graphical user interface, and also we're going to do program from the point of view of program efficiency. So at least in this case, we will take all user inputs, whether they are right or wrong, and only then proceed for processing. Of course, if input is an error, pizza will not be built. We'll just tell them what input error is. That problem is solved in graphical environment because graphical environment has radio buttons, checkboxes, etc. If I have time, I will show you one of those too, although built in other languages like C# or Java and things like that. Okay, let's describe the problem. Simulate a pizza store. When ordering one pizza, you can only order one size, which has certain diameter, but you can order 0 to maximum number of toppings that store offers. And Elegant Store may offer different flour types for the pizza crust. Like if you go to Blade Pizza, they offer different crusts, and also like they can offer you different cheese types, and of course different toppings. Okay, so what we have already decided for you in building this software is that we are just going to decide on input values for different pizza parameters. They're doing that for design ease. In real life, customer is not going to tell you any of the information that I'm going to show you, different tables. You can choose whatever you want. But here, we want to reduce the design load. So we're going to fix certain constants for different inputs that will correspond to different pizza parameters. So we'll first have a table of basic cost. What is basic cost? That is the cost of the crust as a function of size. That's the basic cost. And all other costs would be function of this basic cost, because basic cost fixes the size. So I'm just going to give an example. If size is 6 inches, and you have to put the cheese on that later, and other size 12 inches, and you put the cheese on that, then obviously cost of cheese on 12 inches size will be more than the 6 inches size. It doesn't have to be proportional, but it'll be more. And same thing with the toppings and the flour. If you use exotic flour, then size, basic cost will change the size also, cost of flour also. So let's look at the basic cost. So code is the basically size code in a way. So it could be a character S. Maybe I should put a apostrophe around it. Same thing here. These are not variable names. These are just constants. So when we ask them pizza size, they will enter either S, M, L, or X. And that gives you an idea of the basic cost. That if they enter S, base cost will be 20, and this will be small pizza. If they enter M, base cost will be $4, and that'll be a medium pizza. Each size has a certain diameter. We're not going to worry about that here. If they enter L for the code, cost will be $6. That'll be large pizza. If they enter X for the code, cost will be $8 and extra large pizza. So basically, when we start the program, we'll ask them, okay, which size pizza you want. Enter S for small, M for medium, L for large, X for extra large, and they're going to enter one of these. And a little bit later, we'll decide the base cost based on that. Okay. Next comes the issue of increments that we have to add into the cost calculation over and above the basic cost. And increments are added to the pizza cost computation, and those would be due to expensive flour used for exotic pizza recipes. For example, organic wheat or multigrain pizza pie may cost more due to higher grain cost. Then you could have exotic cheese as your topping, and that may be extra cost. And then you may have no topping or many toppings. That's extra cost also. So we have tables 2, 3, and 4 giving you parameters for computing those. Okay, let's look at those. So over and above base cost, we're going to have this cost increment due to the flour. So if you have regular flour, obviously there's no extra cost. You have to sell them pizza. So that's just the base cost. And once again, code we have fixed here. In real software application, you will not be given those. Here we are giving that to just make our life easier. So program will ask them, what flour do you want? Enter 0 for regular, 1 for whole wheat, 2 for organic whole wheat, 3 for multigrain, and I believe Blaze Pizza has gluten-free, which is tapioca flour. Okay, so if you want to extend that program, you can just make a visit to Blaze Pizza and see what different flours they have. So no extra cost due to flour if they want regular flour. But if they want whole wheat, then we add 2% of the base cost. That means, okay, let me kind of explain that. Maybe I can use this document to do some rough calculation. Let's say they ordered small pizza, which is $2. And then they ordered whole wheat crust or pie. Then $2 into 2% will be, let me just use this space to do some calculation, 2.0 into 0.02. How much is that? 0.04. So we'll add 4 cents if they want whole wheat flour. We'll send 8 cents, add 8 cents if they want organic whole wheat, or 12 cents if they want multigrain. So that's how base cost will affect cost increment due to more expensive flour. This is very crucial that you understand this step. Otherwise, you won't know what to do. Okay? Some people just multiply 2 with the base cost. That's completely wrong. You can just understand that to calculate this increment, we just take this percentage. If you want to use that, then that's fine. Multiply by base cost, divide by 100. So the other way you can do is this, that 2.0. If it's a small pizza, into 2, divide by 100. And I'm cautioning you, I have seen very, very advanced students making this error. They just do this. That's wrong. Okay. All right. A little bit later, algorithm will clarify this once again. Next is, if they want just regular cheese, they don't have to pay extra. But they want exotic cheese, then extra is added. Once again, related to the base cost, plus some extra. No, actually in this case, there are no extras. So, further component of the cost that increases the cost is cheese type. And once again, we have chosen the codes, input constants. Constants that will be used to compare user input. These are these. If they want regular cheese, obviously you can make pizza without any cheese. We charge nothing extra for that. But if they want extra cheese, like one more layer of cheese, then we add extra 1% of the base cost. If they want jalapeno cheese, code for that will be J. We add 2% of the base cost. Goat cheese expensive, they want goat cheese, then we add 5% of the base cost. And basis of computing these is the same. You take these numbers, multiply by base cost, divide by 100. Okay? Very simple. And all increments are added together to the base cost to find the final cost. Finally, we need to compute cost increment due to toppings. This is, we have taken a simpler approach here. In real ideal world, you should be able to order any number of toppings, 1, 2, 3, all of them, any combination. If we allow that, our software will become too complicated. So we are not allowing them. We are allowing either any one or all. Obviously, that's not the case in real world, but we wanted to keep our program simple, so that's what we're doing. So here, I have 3 columns in this table. Toppings could have code 0, 1, 2, 3, 4, 5. You can add more codes, doesn't matter. Types are these, and these are the additional codes cost for the toppings. If you want no topping, no extra cost. But if you want mushrooms, you'll enter code 1. Choices will be displayed to you at the time of input. You had 50 cents on the top plus 1% of the base cost. So in that case, cost has 2 components. This extra increment due to topping has 2 components, 50 cents into base cost into 1 divided by 100. And so on for shrimp, olives, peppers. But if you want all of the toppings, we'll add all these costs together. And the formula, when we do it in algorithm, and don't remember whether I showed that in the Boolean tables or not. I might have. We'll revisit them at that time. So once again, goal of software is take all user input, even if one of them is wrong. If they're all correct, you process pizza cost using these table 1, 2, 3, and 4, and we tell them that okay, your pizza will be built, and we tell them in whole dollars and cents what their cost is. If one of their input, they're making 4 inputs, actually 5 including their first name, but if any of the 4 cost related input is wrong, or all 4 are wrong, we tell them which of their inputs are wrong, and pizza cannot be built, and they have to reorder. In this case, in graphical user interface, it'll give the instant feedback. Only wrong or errant inputs will have to be fixed. But this is command line, so we cannot do that. All right, so that was the problem description. So it's very important that you do things in 1 or 2 ways. This document I'm seeing here will be available. You can read the document first, then watch the video. You can watch the video, then read the document, or you can watch the video on one computer and have the document open in second device, could be your phone, or you may be watching video on the phone and have document open on your computer. So that might help you understand things a little bit faster. Okay, so that's the end of video 105, pizza cost calculation and order processing, design example 4, and we'll very soon see you in video number 2, where we'll discuss the analysis.